In this episode of my series on terraforming Venus, I'll explore the compelling reasons why Venus, despite its hellish surface conditions, might be a more suitable candidate for terraforming than Mars. The idea of transforming an entire planet into a habitable environment is daunting, and when considering which planet to target, Mars often steals the spotlight. However, Venus, often referred to as Earth's twin due to its similar size and gravity, presents unique advantages that make it a strong contender for becoming humanity's second home. Howdy, I'm just some random nude dude sitting in my closet talking to myself. It's also where I celebrate the power of free thinking and encourage bold ideas. As a society, we're often afraid to challenge the norms or think outside the box. But here, I embrace the unconventional. So sit back, relax, and join me on this journey of exploration, where we embrace our inner nude dude and push boundaries to discover new perspectives. In the quest to expand humanity's presence beyond Earth, two celestial neighbors have captured our imagination like no others, Mars and Venus. These two planets, while vastly different in many ways, represent the most viable candidates for terraforming and human colonization in our solar system. Mars, with its cold deserts and thin atmosphere, has long been the poster child for human settlements, thanks in part to its relatively moderate challenges and extensive exploration by robotic missions. Venus, on the other hand, has often been dismissed as too hostile, too extreme, and too challenging to consider for colonization, let alone terraforming. In short, it's too hard. However, as we delve deeper into the possibilities of making another world habitable, Venus emerges as a contender that cannot be ignored. Its proximity to Earth, similar gravity, and potential for creating a more Earth-like environment make it an intriguing and perhaps even superior candidate for human expansion. But to truly understand the potential of Venus, we must first compare it to Mars, the planet that has dominated our spacefaring ambitions for decades. Let's embark on a comprehensive exploration of the strengths and weaknesses of both Mars and Venus as candidates for terraforming and colonization. We'll examine the unique advantages that Venus offers, from its proximity to Earth and its energy potential, to the possibilities of creating a stable Earth-like environment. At the same time, we'll confront the significant challenges that Venus presents, challenges that are as formidable as they are fascinating. Through this comparison, I aim to shed light on why Venus might deserve a second look as humanity's next home. By understanding the relative merits of both planets, we can better evaluate where our efforts and resources should be directed as we take the first steps towards transforming another world into a place where humans can live, thrive, and build a future. Join me as we dive into the critical analysis of Venus and Mars and explore why the seemingly inhospitable Venus could hold the key to a new frontier for humanity. When we think about terraforming, Mars often seems like the obvious choice. Its relatively mild conditions, historic fascination, and the focus of numerous space missions make it a poster child for human colonization. However, when we dig deeper into the requirements for creating a truly habitable world, Venus emerges as a surprisingly strong contender. This section explores the reasons why Venus might actually be a more suitable candidate for terraforming than Mars, despite its current hostile environment. One of the most significant advantages Venus holds over Mars is its gravity. Venus has a surface gravity that's approximately 90% of Earth's, 0.9 g, making it almost identical to the environment we evolved in. This similarity in gravity is crucial for long-term human health. Our bodies are finely tuned to Earth's gravity, and significant deviations can lead to serious health issues. On Mars, gravity is only about 38% of Earth's. which presents a number of potential problems. Prolonged exposure to low gravity can cause muscle atrophy, bone density loss, and other health issues that we are only beginning to understand. While the full effects of living in such an environment over generations are unknown, the risks are substantial. Children born and raised in low gravity of Mars might develop differently than those on Earth, potentially making them less able to function in Earth's gravity or other environments with higher gravity. The challenges of adapting to such a drastically different gravity field could complicate not just individual health, but the entire prospect of long-term colonization. In contrast, the Earth-like gravity of Venus would mean that humans could live, work, and thrive without the same level of concern for these health issues. The similarity of Earth's gravity makes Venus an attractive option for a more seamless transition to life on another planet, reducing the physiological stress that would come from adapting to a different gravitational environment. Another critical factor in choosing a planet for colonization is the level of protection it offers against cosmic radiation. Mars' thin atmosphere and lack of a strong magnetic field leave its surface exposed to high levels of solar and cosmic radiation. This radiation poses significant risks to human health, including increased chances of cancer, damage to the central nervous system, and other harmful effects that could shorten the lifespan of colonists or make the environment unsafe for long-term habitation. To live on Mars, significant infrastructure would be required to protect inhabitants from radiation. This could include living underground or building extensive shielding around habitats, both of which add complexity and cost to any colonization effort. In contrast, Venus's thick atmosphere provides a natural shield against cosmic and solar radiation. The dense blanket of gases, while currently composed of toxic carbon dioxide and sulfuric acid, is thick enough to absorb and block much of the harmful radiation that would otherwise reach the surface. This natural protection would reduce the need for extensive radiation shielding, making the surface environment potentially safer for human life once the atmospheric composition is altered enough through terraforming. The ability to leverage Venus's natural radiation protection is a significant advantage over Mars, where the lack of a protective atmosphere would require costly and complex solutions to ensure human safety. The surface conditions of Mars and Venus are both challenging, but in different ways. Mars is cold, with average surface temperatures around 80 degrees below zero Fahrenheit or 62 degrees below zero Celsius, and its thin atmosphere provides little insulation. This means that any human settlement on Mars would need to contend with extreme cold, which would require energy-intensive heating systems and specially designed habitats to maintain livable conditions. Venus, on the other hand, presents the opposite challenge: extreme heat. The surface temperature of Mars is around 900 degrees Fahrenheit, 475 Celsius, hot enough to melt lead. This intense heat is largely due to a runaway greenhouse effect caused by its thick atmosphere of carbon dioxide. While this seems like a significant drawback, it also means that Venus's surface conditions are the result of its atmospheric composition, which can be theoretically altered through terraforming efforts. If we can find ways to cool Venus's surface by reducing the greenhouse effect, such as reflecting sunlight away from the planet or altering the atmosphere's composition, the planet's size and gravity would make it a potentially much more Earth-like environment. Venus's temperature regulation could be managed through advanced technologies that might one day allow us to create a stable, temperate climate suitable for human life. Mars, with its thin atmosphere, lacks the ability to easily retain heat, meaning that even with extensive terraforming, it would likely remain a cold, dry world. Venus, however, has the potential to be transformed into a warm, water-rich environment much closer to Earth's ideal conditions once the atmospheric challenges are addressed. Resource availability is another crucial factor when considering which planet to terraform. Mars is often depicted as a barren world with limited natural resources, particularly when it comes to water and minerals necessary for sustaining human life and building infrastructure. While Mars does have water in the form of ice and possibly some underground reservoirs, it's still a relatively dry planet compared to Earth. Venus, despite its inhospitable surface, is rich in resources that could be valuable for terraforming and colonization. The planet's atmosphere is filled with carbon dioxide, which could be used as a source of carbon and oxygen. Sulfuric acid in the clouds could be converted into water and sulfur, both of which could be utilized in various industrial processes. Additionally, Venus is thought to have a geologically active surface, with volcanic activity that could provide access to a wide range of minerals. The geological activity on Venus suggests that it might have a more dynamic interior than Mars, which is largely geologically inactive. This activity could be harnessed to provide the raw materials necessary for constructing habitats, manufacturing goods, and sustaining a growing population. The availability of these resources on Venus, combined with its Earth-like gravity and atmospheric protection, make it a compelling candidate for large-scale human settlement. When considering the long-term potential for human colonization, Venus offers several key advantages over Mars. While both planets present significant challenges, the similarities between Venus and Earth in terms of gravity, atmospheric protection, and potential for a stable environment make it a more promising candidate for creating a truly Earth-like world. Terraforming Venus would be a monumental task, requiring unprecedented technological advancements and international cooperation. However, the rewards could be immense, a second home for humanity that mirrors the conditions of Earth, offering a safe, sustainable environment for future generations. Mars, with its low gravity and thin atmosphere, would always be more challenging and less hospitable an environment, even after extensive terraforming. Venus's potential to become a stable, Earth-like world makes it a compelling option for those looking to expand humanity's reach beyond our home planet. While Mars may be easier to reach and has been the focus of much attention, Venus's unique advantages make it a candidate that deserves serious consideration. As we continue to explore the possibilities of terraforming, Venus stands out as a world with the potential to truly become a new cradle for human civilization. One of the most significant yet often overlooked advantages of Venus over Mars when considering terraforming and colonization is its proximity to Earth. The distance between a potential colony and Earth is a crucial factor in determining the feasibility, cost, and overall success of interplanetary colonization. Venus, being the closest planet to Earth, offers several key benefits that could make it a more viable candidate for human expansion into the solar system. Venus's average distance from Earth is about 41 million kilometers, while Mars is about 78 million kilometers away. This closer proximity translates directly into shorter travel times. A spacecraft traveling from Earth to Venus could make the journey in as little as 3 to 4 months, depending on the alignment of the planets and the specific mission trajectory. In comparison, a trip to Mars can take anywhere from 6 to 9 months under optimal conditions. This difference in travel time has profound implications for the logistics of colonization. Shorter travel times mean that missions to Venus could be more frequent and flexible, allowing for more timely delivery of supplies, equipment, and personnel. This is especially important during the early stages of colonization, when regular supply missions are critical to the survival and growth of any settlement. If an emergency were to arise in a Venusian colony, aid from Earth could arrive much more quickly than if the colony were on Mars. The closer distance to Venus also significantly reduces the cost of transporting materials and people between Earth and Venus. Supply missions are incredibly expensive, with a large portion of the costs coming from fuel and resources needed to cover the vast interplanetary distances. The shorter distance, the less the fuel required, and the lower the overall mission cost. In the long term, reduced transportation costs would make Venusian colonization more economically feasible. It would allow for a steady flow of goods and materials, supporting the development of infrastructure on Venus and enabling the colony to grow more rapidly. The ability to send frequent shipments at a lower cost would also make it easier to build and maintain the complex systems required for terraforming and sustaining human life on Venus. Moreover, this economic advantage would make it easier to establish trade routes between Venus and Earth. While Venus might initially rely on Earth for many essential goods, over time it could become a hub of resource extraction and production, with valuable materials being sent back to Earth. The economic potential for such trade could offset some of the costs associated with terraforming and making the entire venture more attractive from a financial standpoint. Communication is another area where Venus's proximity offers significant benefits. In space, communication delay is a critical factor. Radio signals, which travel at the speed of light, take about 3 to 15 minutes to reach Mars from Earth, depending on the planet's relative position in their orbits. This delay can make real-time communication and coordination challenging, especially in emergency situations or when quick decision-making is required. Venus, being closer, has a much shorter communication delay, typically around 2 to 6 minutes. This reduced delay allows for more effective communication between Earth and a Venusian colony. Faster communication could facilitate better management of the colony, more efficient problem solving, and a stronger connection between the settlers and their support teams back on Earth. Additionally, the shorter communication delay could have a psychological benefit for the colonists. Knowing that they are in more immediate contact with Earth could reduce feelings of isolation and increase their overall morale. The ability to maintain more consistent and rapid communication with loved ones, scientists, and mission control on Earth would help build a sense of community and support, making the challenges of living on another planet more bearable. Another practical advantage of Venus's proximity is the frequency of launch windows. Due to orbital dynamics of the solar system, launch windows to other planets open at specific intervals. These windows are the periods when the planets align in such a way that the journey from one to the other requires the least amount of energy. For Mars, these optimal launch windows occur approximately every 26 months, which means the opportunities to send missions are relatively infrequent. Missing a launch window can lead to long delays, complicating mission planning and the timing of supply deliveries. In contrast, launch windows to Venus occur more frequently, approximately every 19 months. This increased frequency allows for more flexible mission planning and reduces the potential for delays. More frequent opportunities to send missions also means that Venusian colonists would not have to wait as long for critical supplies or reinforcements, making the overall colonization effort more resilient to setbacks. The proximity of Venus to Earth offers significant psychological and social benefits for potential colonists. The shorter distance means that colonists would not feel as isolated from Earth as they might on Mars. This closer connection could foster a stronger psychological well-being among settlers, as they would feel that Earth is not so far away. The ability to maintain more frequent and real-time communication with family, friends, and Earth-based support systems could alleviate the loneliness and stress associated with living on another planet. Knowing that they're relatively close to home could provide a sense of security and comfort, making the transition to life on Venus easier for many people. Moreover, the closer distance could make Venus a more attractive destination for potential colonists. The idea of living on a planet that is within relatively easy reach of Earth might appeal to those who are hesitant about the idea of being so far away from home. This could help attract a more diverse and robust population to Venus, which would be critical for the long-term success of the colony. From a strategic standpoint, the proximity of Venus also offers advantages in the terms of economic and geopolitical considerations. Being closer to Earth, Venus could become a vital link in an interplanetary economy, serving as a key hub for resource extraction, manufacturing, and trade. The economic benefits of having a thriving colony so close to Earth could be immense, fueling further space exploration and colonization efforts. Moreover, Venus's proximity could make it a strategically important location for future space endeavors. As humanity expands its presence in the solar system, Venus could serve as a stepping stone for missions to other planets or as a base for deeper space exploration. The ability to quickly and efficiently travel between Earth and Venus would make the planet a critical asset in humanity's ongoing quest to explore and settle the solar system. The proximity of Venus to Earth offers a clear and compelling advantage in the context of terraforming and colonization. The shorter travel times, reduced transportation costs, enhanced communication, and psychological benefits make Venus a more feasible and attractive option for large-scale human settlement. While the challenges of terraforming Venus are significant, its proximity to Earth provides a logistical and strategic edge that could make it the endeavor not only possible, but highly advantageous. As we continue to explore the potential of terraforming Venus in this series, it becomes increasingly evident that its closeness to Earth could play a pivotal role in the future as a human colony. The benefit of proximity, combined with Venus's other unique characteristics, make it a strong candidate for becoming humanity's next great frontier. One of the most critical factors in the success of any terraforming project is the availability and harnessing of energy. A project as ambitious as terraforming an entire planet's environment requires an immense amount of energy to power everything from atmospheric processing to the construction and maintenance of infrastructure. Venus, with its unique environmental conditions, offers several promising avenues for energy generation that could make terraforming not only feasible, but sustainable in the long term. This section delves into the various energy sources available on Venus and explores how they can be harnessed to support both terraforming and a thriving human colony. Venus's proximity to the Sun is one of its most significant energy-related advantages. Venus receives about 1.9 times the solar energy per unit area compared to Earth due to its closer orbit. This abundance of solar energy makes Venus an ideal candidate for solar power generation, which could serve as the primary energy source for both the terraforming process and the subsequent human settlement. Solar panels deployed on Venus could be able to generate significantly more electricity than those on Earth or Mars. The high solar insolation could be harnessed using advanced photovoltaic technology, potentially providing a reliable and virtually limitless supply of clean energy. Additionally, the high energy output of solar panels on Venus could reduce the overall number of panels needed to generate the same amount of power, minimizing the material and logistics costs associated with their deployment. However, Venus's dense atmosphere and thick cloud cover, which reflect a significant portion of incoming sunlight, present challenges to surface-based solar power generation. These clouds, composed primarily of sulfuric acid, are highly reflective and contribute to the planet's high albedo. Despite this, there are several ways to effectively harness solar energy on Venus. One solution is to deploy solar power stations in the upper atmosphere, above the cloud layer. These stations could capture the full intensity of sunlight without interference from the planet's reflective clouds. Solar energy collected at these high altitudes could then be beamed to the surface or to floating cities using microwave or laser transmission. Alternatively, orbiting solar power satellites could capture sunlight and transmit energy to the surface or to high-altitude platforms, ensuring a continuous and steady supply of power. Floating solar platforms, or cloud cities equipped with solar panels, could also take advantages of Venus's abundant sunlight. These platforms, positioned above the cloud layer, would have access to sunlight nearly 24/7, as Venus's slow rotation results in long days and nights. The consistent availability of sunlight makes solar power a particularly attractive energy source for Venus, providing a steady and reliable power supply of electricity to support both terraforming and human habitation. Venus is believed to have a geologically active surface with numerous volcanoes and a potentially molten interior. This geologic activity suggests that Venus may have a substantial geothermal energy reserves, which could be harnessed as a secondary energy source. Geothermal energy, which is generated by tapping into the heat from the planet's interior, could be particularly valuable for powering industrial processes and maintaining infrastructure. On Earth, geothermal energy is extracted by drilling into the ground to access hot water or steam, which is then used to drive turbines and generate electricity. A similar approach could be employed on Venus, where the planet's volcanic activity might provide abundant heat sources just below the surface. Geothermal power plants could be constructed near volcanic regions, where the heat from the magma could be used to produce electricity. The use of geothermal energy on Venus would have several advantages. First, it's a consistent and reliable energy source, unaffected by the day-night cycle or weather conditions. Second, geothermal plants could be located near industrial centers or settlements, reducing the need for long-distance energy transmission. This proximity would be particularly beneficial in the early stages of colonization, when energy demands are high and infrastructure is still being developed. Additionally, geothermal energy could be used to support terraforming efforts. For example, the heat generated from geothermal sources could be used to power atmospheric processing plants, which would work to alter the composition of Venus's atmosphere. This energy could also be used in the production of hydrogen, oxygen, and other critical resources through the electrolysis and other processes supporting both life support systems and industrial activities. Venus is known for its super-rotating atmosphere, where winds in the upper atmosphere move above speeds of 360 kilometers an hour, far faster than the planet's surface rotation. These high-speed winds present a significant opportunity for generating wind energy, particularly at high altitudes where the winds are strongest. Wind turbines could be deployed on floating platforms or cloud cities in the upper atmosphere to capture the kinetic energy of these winds. The consistent and high-speed winds in Venus's upper atmosphere could drive large turbines, producing a substantial amount of electricity. This energy could then be stored in batteries or used directly to power various systems and processes. Wind energy could play a complementary role alongside solar and geothermal energy, providing additional power during periods when solar energy might be less available, such as during Venus's long night phase. The consistent nature of Venus's atmospheric winds means that wind power could be a reliable and continuous energy source, helping to balance the energy grid and ensure a steady supply of power for both terraforming and human activities. Furthermore, the use of wind energy on Venus would be particularly advantageous in regions where other energy sources are less viable. For instance, in areas with less access to geothermal resources or where solar power might be less effective due to atmospheric conditions, wind energy could provide a viable alternative. In addition to solar, geothermal, and wind energy, Venus offers the potential for energy generation through chemical processes and, in the future, nuclear fusion. Venus's atmosphere is rich in carbon dioxide and sulfuric acid, both of which could be used in the chemical reactions to produce energy or valuable compounds. For example, carbon dioxide could be used in the Sabatier reaction, which converts carbon dioxide and hydrogen into methane and water. This reaction could be harnessed to produce fuel or energy, particularly if hydrogen can be sourced from Venus's atmosphere or imported from Earth. Similarly, sulfuric acid could be used in various industrial processes to produce electricity or other useful materials. Looking further into the future, nuclear fusion presents an intriguing possibility for energy generation on Venus. Fusion, the process that powers the sun, involves fusing hydrogen atoms to produce helium and releasing vast amount of energy. If controlled fusion technology can be developed and implemented, it could provide an almost limitless and clean energy source. Venus's atmosphere contains traces of deuterium, a potential fuel for fusion reactions. While the concentration is low, it could still be extracted and used in fusion reactors. The development of fusion energy would revolutionize energy generation on Venus, providing the vast amounts of power needed for large-scale terraforming and the maintenance of an advanced human civilization. One of the key challenges in utilizing these energy sources on Venus is the need for efficient storage and distribution systems. Due to the planet's harsh surface conditions, energy storage systems would need to be highly robust and capable of operating under extreme temperatures and pressures. Advanced battery technology, possibly using new materials that can withstand Venus's environment, would be essential for storing energy generated by solar, wind, or geothermal sources. These batteries could then supply power during periods when energy generation is low, ensuring a continuous and reliable supply for all planetary operations. Energy distribution on Venus would also require innovative solutions. Given the planet's dense atmosphere and corrosive conditions, traditional power lines may not be practical. Instead, wireless energy transmission methods, such as microwave or laser beams, could be used to transmit energy from high-altitude platforms or orbiting satellites to the surface or other parts of the planet. These systems would need to be carefully designed to minimize energy loss and ensure safe and reliable power delivery across the planet. The energy potential of Venus is both diverse and abundant, offering multiple pathways to power the ambitious project of terraforming the planet. Solar, geothermal, wind, and chemical energy sources each bring unique advantages that, when combined, could create a robust and resilient energy infrastructure capable of supporting both the transformation of Venus and the establishment of a sustainable human presence. By harnessing the immense solar energy available in Venus's orbit, tapping into the planet's geothermal heat, exploiting the high-speed winds in the atmosphere, and potentially developing advanced fusion technology, humanity could unlock the energy needed to turn Venus into a thriving, Earth-like world. The challenges are significant, but the opportunities are equally vast, making Venus a compelling candidate for the next stage of human exploration and settlement in the solar system. Terraforming Venus is not just about transforming its atmosphere and climate. It's also about utilizing and managing the planet's physical landscape and abundant natural resources. Despite its hostile environment, Venus possesses a stable surface and a wealth of resources that could be instrumental in supporting both the terraforming process and the eventual establishment of a self-sustaining human colony. Venus's surface is both a challenge and an opportunity. It's primarily composed of vast plains, large volcanic regions, and a relatively small number of mountain ranges and impact craters. The planet's surface is young, geologically speaking, with estimates suggesting that it was resurfaced by volcanic activity around 300 to 500 million years ago. This resurfacing has resulted in a planet with fewer impact craters compared to other rocky planets like Mars or Mercury, indicating a more stable surface that is less impacted by asteroid collisions. The stability of Venus's surface is crucial for any large-scale terraforming project. A stable surface minimizes the risk of catastrophic events, such as massive earthquakes or large-scale volcanic eruptions, which could disrupt both the terraforming efforts and the infrastructure of human settlements. While Venus does have more active volcanoes, the overall surface appears to be relatively stable compared to the more seismically active Earth. The composition of Venus's surface includes basaltic rock, similar to what is found in Earth's ocean floors and volcanic regions. This rock is rich in minerals such as iron, magnesium, and silicon, which are essential for construction and manufacturing. Additionally, Venus's surface is believed to contain large amounts of sulfur, a byproduct of volcanic activity, which could be used in various industrial processes. One of the major challenges posed by Venus's surface is its extreme temperature, averaging around 467 degrees Celsius, and the high atmospheric pressure, which is around 92 times that of Earth at sea level. These conditions make it difficult to operate machinery or conduct surface mining activities. However, advancement in material science and robotics could eventually overcome these obstacles, enabling the extraction and utilization of surface resources. The rich mineral deposits on Venus offer a wealth of resources that could be crucial in the terraforming process and the establishment of a colony. The basaltic rock, which covers much of Venus's surface, is a valuable resource of raw materials, including metals like iron, nickel, and magnesium. These metals could be extracted and processed to build infrastructure, machinery, and habitats, reducing the need to transport these materials from Earth. Advanced mining techniques, possibly using autonomous robots or remotely operated vehicles, could be developed to operate in Venus's harsh environment. These machines would need to withstand extreme temperatures and pressures, as well as the corrosive effects of the atmosphere. Technologies such as heat-resistant alloys, high-temperature electronics, and protective coatings would be essential for successful mining operations on Venus. In addition to metals, Venus's surface may contain significant amounts of sulfur and other volcanic byproducts. Sulfur could be used in the production of sulfuric acid, which, despite being a hazardous substance, has numerous industrial applications, including the manufacture of fertilizers, chemicals, and batteries. The presence of sulfur on Venus could also support efforts to create artificial soil or other materials necessary for the establishment of agriculture and green spaces as part of the terraforming process. One particularly intriguing possibility is the extraction of materials from Venus's atmosphere. The atmosphere is composed primarily of carbon dioxide with clouds of sulfuric acid. Technologies could be developed to capture and process these gases, converting them into useful compounds such as oxygen, water, and hydrocarbons. These processes would not only help to reduce the concentration of greenhouse gases in the atmosphere, but also provide a vital resource for the colonists. For example, carbon dioxide could be split into carbon and oxygen through the electrochemical or photochemical processes. The oxygen could be used to support human life, while carbon could be used in various industrial processes, including the production of construction materials or synthetic fuels. Similarly, sulfuric acid could be broken down into sulfur and water, with the water being used for life support and agriculture. One of the most significant uses of Venus's surface resources would be in the construction of infrastructure. The basaltic rock prevalent on the planet could be processed into various forms of concrete, bricks, and other building materials. This would allow colonists to construct habitats, roads, and other necessary structures using locally sourced materials, reducing the dependency on supplies from Earth. The creation of a sustainable infrastructure on Venus would require a deep understanding of the planet's geology and the development of new construction techniques. Buildings and other structures would need to be designed to withstand Venus's extreme conditions, including high temperatures, pressures, and the corrosive atmosphere, at least until we change it. This could involve the use of advanced insulating materials, protective coatings, and structural designs that minimize the impact of a harsh environment. In addition to traditional construction materials, Venus's surface could also be a source of exotic materials that are rare or difficult to obtain on Earth. For example, Venus might have deposits of rare metals and other elements that could be valuable for advanced technology or the manufacturing processes. The discovery and exploitation of these resources could provide economic incentives for further exploration and development of the planet. As discussed previously, the planet offers several avenues for energy generation, including solar, geothermal, and wind energy. The energy sources could be supplemented by the extraction and use of Venus's surface resources. For example, Venus's volcanic activity could be harnessed to provide geothermal energy, tapping into the heat generated by the planet's interior. This geothermal energy could power industrial processes, including the extraction and processing of minerals and gases from the surface and atmosphere. The use of geothermal energy could also help to reduce the overall energy requirements of terraforming by providing a consistent and reliable power source. Moreover, the potential for chemical energy production from Venus's atmospheric gases could be another valuable resource. By converting carbon dioxide into oxygen and hydrocarbons, or sulfuric acid into water and sulfur, colonists could produce fuels, chemicals, and other essential materials directly from the planet's environment. This would not only support the energy needs of the colony, but also contribute to the overall terraforming efforts by gradually altering the composition of Venus's atmosphere. While Venus's surface is currently inhospitable to life, the planet's rich mineral content could eventually support agriculture once the environment has been sufficiently altered. The basaltic rock on Venus is rich in nutrients such as iron, magnesium, and calcium, which are essential for plant growth. Once the atmosphere has been cooled and the pressure reduced, these minerals could be used to create fertile soil, either through the direct cultivation of the surface or by producing artificial soil in controlled environments. In addition to traditional soil-based agriculture, hydroponics or aeroponics could be employed to grow crops in Venus's atmosphere using nutrients extracted from the planet's surface and atmosphere. The development of agriculture on Venus would be a critical step in creating a self-sustaining colony, reducing the need for food imports from Earth and providing the colonists with a stable and reliable food source. Venus's stable surface and rich resources present a wealth of opportunities for supporting both the terraforming process and the establishment of a human colony. By harnessing the planet's abundant materials, metals, and atmospheric gases, humanity could build an infrastructure needed to transform Venus into a hospitable world. The challenges are immense, but the rewards are equally great, offering the potential to create a new home for humanity on our closest planetary neighbor. As we continue to explore the possibilities of terraforming Venus, it becomes clear that the planet's surface and resources will play a central role in this ambitious endeavor. With the right technologies and strategies, Venus could be transformed from a hostile, barren landscape into a thriving, Earth-like environment capable of supporting life for generations to come. Terraforming Venus represents one of humanity's most ambitious goals, transforming an alien world into a place that closely resembles Earth, both in its environmental conditions and its capacity to support life. While this may sound like science fiction, the potential to create a truly Earth-like environment on Venus is grounded in scientific principles and the unique characteristics of the planet itself. The ultimate objective of terraforming Venus is to replicate the conditions found on Earth, making the planet habitable for humans and other forms of life. This involves several key goals. Venus's surface temperature currently averages around 467 degrees Celsius, hot enough to melt lead. The ultimate objective of terraforming Venus is to replicate the conditions found on Earth, making the planet habitable for humans and other forms of life. This involves several key goals. Venus's surface temperature currently averages around 467 degrees Celsius, hot enough to melt lead. One of the first and most critical steps in terraforming Venus is to drastically reduce this temperature to levels comparable to Earth's. Achieving this would involve both reducing the amount of solar radiation reaching the surface and altering the planet's atmospheric compositions to decrease the greenhouse effect. The atmosphere of Venus is composed of about 96.5% carbon dioxide, with clouds of sulfuric acid. For Venus to support life, this atmosphere would need to be transformed into a mixture similar to Earth's, with breathable levels of oxygen and nitrogen. This would require removing or converting the vast amounts of carbon dioxide and sulfuric acid, and introducing the right balance of gases to create a stable and life-sustaining environment. The atmospheric pressure on Venus's surface is approximately 92 times that of Earth at sea level. Reducing this pressure to Earth-like levels is essential for human survival and for the operation of most Earth-based machinery and habitats. This could involve both thinning the atmosphere and redistributing gases to the upper atmosphere or even into space. Water is the foundation of life as we know it, and introducing significant amounts of water to Venus is crucial for creating a habitable environment. This could involve importing water from other celestial bodies, like icy moons or asteroids, or generating water on Venus through chemical reactions, such as combining hydrogen with oxygen. Unlike Earth, Venus lacks a strong magnetic field to protect it from solar and cosmic radiation. Generating a magnetic field or creating artificial shields would be necessary to protect life on the planet and maintain a stable atmosphere over long periods. Once the physical environment of Venus has been sufficiently altered, the next step would be to introduce life forms, beginning with hardy microorganisms and plants that can help further transform the environment. Eventually, larger plants, animals, and finally humans could be introduced, creating a fully functional ecosystem. One of the most daunting challenges in creating an Earth-like environment on Venus is cooling the planet. Venus's extreme temperatures are primarily due to its thick atmosphere, which traps heat through an intense greenhouse effect. To bring Venus's surface temperature down to Earth-like levels, several strategies could be employed. One approach involves the use of reflective solar shields placed in orbit between Venus and the Sun. These shields would reduce the amount of sunlight reaching the planet, helping to cool the surface over time. Another method could involve seeding the upper atmosphere with reflective particles or aerosols to increase the planet's albedo, further reducing the amount of heat absorbed by the surface. In addition to these techniques, altering the atmospheric composition to reduce the greenhouse effect would be crucial. This could involve removing large quantities of carbon dioxide, either by converting it into other substances or by sequestering it underground or in solid form. The introduction of certain chemicals or life forms that can absorb or react with carbon dioxide might help in this process. The current atmosphere of Venus is not only hot, but also toxic, with high concentrations of carbon dioxide and sulfuric acid. Transforming this environment into one that is breathable for humans would be a monumental task, but is theoretically possible with the right technologies. One potential solution is to use large-scale atmospheric processing plants which could extract carbon dioxide from the air and convert it into oxygen and other useful gases. This could be done through chemical processes such as the Sabatier reaction, which combines carbon dioxide with hydrogen to produce methane and water. The water could then be split into hydrogen and oxygen, with the oxygen being released into the atmosphere. Another approach could involve introducing genetically engineered microorganisms or plants that could absorb carbon dioxide and produce oxygen through photosynthesis. These organisms could be designed to thrive in the harsh conditions of Venus's atmosphere, gradually transforming it over time. Reducing the sulfuric acid content of the atmosphere is another challenge. This could be achieved by chemical reactions that neutralize the acid, converting it into water and sulfur, both of which could be used in other aspects of the terraforming process. The immense atmospheric pressure on Venus's surface poses a significant challenge for human habitation. Reducing this pressure to Earth-like levels would require thinning the atmosphere, either by removing gases or by expanding the atmosphere's volume. One way to reduce atmospheric pressure is to capture and remove large amounts of carbon dioxide, as previously mentioned. Another approach would involve the use of massive gas collection systems that could siphon off excess gases and either store them in orbiting facilities or release them into space. Alternatively, creating vast high-altitude habitats or floating cities in the upper atmosphere, where the pressure is more similar to Earth's, could provide a more immediate solution for human settlement while the surface is being transformed. Introducing water to Venus is crucial for creating an Earth-like environment. Water is necessary not only for supporting life, but also for regulating temperature, for forming weather patterns, and shaping the landscape. Several methods could be used to introduce water to Venus. One possibility is to import water-rich comets or icy asteroids and direct them to collide with the planet. This ice would vaporize on impact, creating water vapor that could be introduced into the atmosphere or condensed to form bodies of water. Another approach could involve generating water on Venus through chemical reactions. For example, hydrogen could be combined with oxygen, possibly extracted from carbon dioxide, to produce water. This water could then be distributed across the planet, forming lakes, rivers, and eventually oceans. Creating large bodies of water would help regulate the planet's climate by absorbing and redistributing heat, reducing temperature extremes, and supporting the development of a stable weather system. This would also provide the necessary conditions for the introduction of plant life and the development of a full biosphere. Unlike Earth, Venus does not have a strong magnetic field to protect its atmosphere from solar wind and cosmic radiation. Without such protection, Venus's atmosphere could be slowly stripped away over time, undoing the terraforming efforts. One potential solution is to generate an artificial magnetic field around Venus. This could be achieved through the construction of large electromagnetic structures in orbit or on the planet's surface. These structures would generate a magnetic field strong enough to shield the planet from solar and cosmic radiation, preserving the atmosphere and protecting life on the surface. Alternatively, a magnetic shield could be placed at the Lagrange point between Venus and the Sun, where it would deflect the solar wind and protect the planet from radiation. This would require advanced engineering and material science, but it could provide a long-term solution to the problem of atmospheric erosion. Once the physical environment of Venus has been sufficiently altered, the next step is to introduce life. The process would begin with hardy microorganisms capable of surviving in the newly transformed environment. These microorganisms would play a crucial role in further stabilizing the atmosphere and enriching the soil, paving the way for more complex life forms. Plants would be introduced next, chosen for their ability to thrive in the new conditions and contribute to the production of oxygen. Over time, as the environment becomes more hospitable, animals could be introduced, creating a full Earth-like ecosystem. The development of a biosphere on Venus would be a gradual process, requiring careful management and monitoring to ensure that the introduced species adapt successfully. The goal would be to create a self-sustaining ecosystem that mirrors the diversity and complexity of Earth's biosphere, providing a stable environment for human habitation. The successful terraforming of Venus would have profound implications for humanity. We'd have to make sure we don't introduce mosquitoes, though. A truly Earth-like Venus would not only provide a new home for millions or even billions of people, alleviating the pressures of overpopulation on Earth, but it would also serve as a backup in the event of a global catastrophe. The creation of a second Earth would also expand the frontiers of human knowledge and technology. The challenges involved in terraforming Venus would drive innovation in fields such as material science, energy production, biotechnology, and environmental engineering. And if we know humans, war. These advancements could have a wide-ranging benefit both on Earth and beyond, as humanity continues to explore and settle other planets in the solar system. Moreover, a terraformed Venus could also serve as a base for further exploration of the solar system. Its proximity to Earth and rich resources could make it an ideal location for launching missions to the outer planets, the asteroid belt, or even interstellar destinations. The potential to create a truly Earth-like environment on Venus represents one of the most exciting possibilities for the future of humanity. While the challenges are immense, the rewards are equally great, offering a chance to expand human civilization beyond Earth and secure our species' long-term survival. The vision of a green, blue, and vibrant Venus, teeming with life and supporting thriving human communities, is one that captures the imagination and inspires hope. It's a vision that, while still far from realization, is grounded in the principles of science and engineering. With determination, creativity, and collaboration, the dream of transforming Venus into a second Earth could one day become a reality, marking a new chapter in the story of human exploration and discovery. Terraforming Venus is an extraordinary endeavor presenting challenges that are unlike any of those faced on any other planet in the solar system. While transforming Mars or the Moon may involve significant obstacles, Venus presents a unique set of difficulties due to its extreme environmental conditions, chemical composition, and lack of a magnetic field. These challenges must be carefully understood and addressed if the vision of a habitable Venus is to be realized. One of the most formidable challenges posed by Venus is its extreme surface conditions. The planet's average surface temperature hovers around 467 degrees Celsius, making it the hottest planet in the solar system, even hotter than Mercury, despite it being further away from the Sun. This intense heat is primarily the result of a runaway greenhouse effect caused by the planet's dense carbon dioxide atmosphere, which traps heat from the Sun. The implications of this extreme heat are profound. It prevents the existence of liquid water on the surface, makes the operation of any Earth-based technology or machinery nearly impossible without significant modifications, and creates an environment that is inhospitable to all known forms of life. Any effort to terraform Venus must therefore begin with the challenge of drastically cooling the planet's surface. Several approaches have been proposed to address this challenge. One concept involves placing large solar shades or mirrors in orbit between Venus and the Sun. These structures would reflect or block a portion of the sunlight, reducing the amount of solar radiation reaching Venus and allowing the planet to cool over time. The scale of such a project would be enormous, requiring advanced materials and engineering, but it could potentially lower the surface temperature significantly. Another approach is to increase the planet's albedo, or reflectivity, by seeding the atmosphere with reflective particles or aerosols. By reflecting more sunlight back into space, this method could gradually reduce the amount of heat trapped in the atmosphere. However, the long-term effects of such an intervention would need to be carefully studied to avoid unintended consequences. A more direct approach involves altering the composition of Venus's atmosphere to reduce the greenhouse effect. This could involve removing or converting large quantities of carbon dioxide, as discussed in the previous sections, thereby reducing the heat-trapping capacity of the atmosphere. While this approach would be highly complex and resource-intensive, it directly targets the root cause of Venus's extreme temperatures. Venus's atmosphere is not only thick, but also composed of toxic gases, primarily carbon dioxide with clouds of sulfuric acid. The atmosphere extends far higher than Earth's, creating a surface pressure of about 92 times that of Earth's at sea level, equivalent to the pressure found nearly a kilometer underwater on Earth. This combination of density, toxicity, and pressure makes the atmosphere one of Venus's most hostile environments imaginable. The high atmospheric pressure poses several challenges. It makes the surface environment extremely challenging for human habitation, requiring habitats and equipment that can withstand immense forces. Even for robotic missions, operating under such high pressure requires specialized design and materials that can resist compression and avoid malfunctions. Reducing this pressure is critical for any terraforming effort. One potential strategy involves thinning the atmosphere by removing or redistributing large amounts of carbon dioxide. This could be done through chemical reactions that sequester CO2 in solid or liquid form, possibly storing it underground or in other stable reservoirs. Another approach involves the gradual expansion of the atmosphere's volume by introducing gases that are lighter and less dense than CO2, thus reducing the overall pressure. The presence of sulfuric acid in the atmosphere adds another layer of complexity. Sulfuric acid is highly corrosive, capable of destroying most materials over time. Any equipment or structures exposed to Venus's atmosphere must be made from highly resistant materials or protected by special coatings. Additionally, the process of removing or neutralizing sulfuric acid from the environment is a significant challenge. Neutralizing sulfuric acid could involve introducing chemical compounds that react with the acid to produce water and less harmful byproducts, such as sulfur or sulfur dioxide. However, this would need to be done on a massive scale to have any meaningful impact on the planet's atmosphere. Another approach might involve creating atmospheric processing plants that can filter and treat the air, gradually reducing the concentration of sulfuric acid over time. Unlike Earth, Venus does not have a significant magnetic field to protect its atmosphere and surface from solar or cosmic radiation. Earth's magnetic field deflects charged particles from the Sun, known as the solar wind, preventing them from stripping away the atmosphere and exposing the surface to harmful radiation. Venus's lack of a magnetic field makes the atmosphere vulnerable to erosion by solar wind, which could gradually strip away any gases introduced during the terraforming process. Without a magnetic field, the surface of Venus is exposed to higher levels of solar or cosmic radiation, which poses risks to both technological systems and biological life. Prolonged exposure to this radiation could damage electronic systems, degrade materials, and pose serious health risks to any potential inhabitants. One possible solution to this problem is the creation of an artificial magnetic field around Venus. This could be achieved through the construction of large electromagnetic structures in orbit or on the planet's surface, designed to generate a magnetic field strong enough to protect the atmosphere and surface from radiation. Alternatively, a magnetic field could be placed at a strategic point between Venus and the Sun, such as the Venus-Sun Lagrange point, where it could deflect the solar wind and provide some level of protection to the planet. This approach would require advanced engineering and energy resources, but could provide a long-term solution to the problem of atmospheric erosion. Venus has an extremely slow rotation period, taking about 243 Earth days to complete one rotation on its axis. Additionally, Venus rotates in the opposite direction of most planets in the solar system, including Earth, meaning that the Sun rises in the west and sets in the east. This slow and retrograde rotation has several implications for the planet's environment and any future attempts to terraform it. The slow rotation results in extremely long days and nights, each lasting about 117 Earth days. This creates significant challenges for temperature regulation, as one side of the planet is exposed to the sun's heat for extended periods, while the other side experiences prolonged darkness. The extreme temperature differences between the day and night sides could complicate efforts to create a stable Earth-like climate. One potential solution to this problem is the creation of a system of orbital mirrors or shades that could help regulate the temperature by reflecting sunlight away from the day side and redirecting it to the night side. This would help balance the temperature and create a more consistent climate across the planet. Another approach could involve the use of atmospheric circulation to distribute heat more evenly around the planet. By creating wind patterns or jet streams that move heat from the day side to the night side, it might be possible to reduce the temperature extremes and create a more temperate environment. Water is essential for life, and the lack of natural water sources on Venus is a significant obstacle to creating a habitable environment. Unlike Earth, which has vast oceans, lakes, and rivers, Venus's surface is dry and barren with no evidence of liquid water. The extreme heat and pressure have likely caused any water that once existed on Venus to evaporate or be broken down into hydrogen and oxygen, with the hydrogen escaping into space. Introducing water to Venus would be a critical step in the terraforming process. As discussed in previous sections, this could be achieved by importing water-rich comets or icy asteroids, directing them to collide with the planet and release their water content. Alternatively, water could be generated on Venus through chemical reactions that combine hydrogen and oxygen, possibly using hydrogen imported from other parts of the solar system. Once water is introduced to Venus, it would need to be carefully distributed and managed to create stable bodies of water to support development of an ecosystem. This would involve the construction of lakes, rivers, and possibly even oceans, along with the development of infrastructure to manage water resources, such as dams, reservoirs, and irrigation systems. Venus's atmosphere is characterized by complex and extreme weather patterns, including fast-moving winds that can reach speeds up to 360 kilometers an hour in the upper atmosphere. These winds, known as superrotation, cause the atmosphere to rotate much faster than the planet's surface, creating dynamic and unpredictable weather conditions. Controlling and stabilizing the weather on Venus would be a significant challenge. The superrotation of the atmosphere, combined with the thick clouds of sulfuric acid and the high surface pressure, makes predicting and managing weather patterns difficult. Like it's easy on Earth, right? This complexity could impact efforts to regulate temperature, distribute water, and create a stable environment for life. One approach to addressing this challenge is to gradually alter the composition and structure of the atmosphere to reduce superrotation and create more Earth-like weather patterns. This could involve introducing gases or particles that increase atmospheric drag, slowing down the winds and stabilizing the climate. Another possibility is to use advanced weather control technologies, such as large-scale atmospheric heaters or coolers, to manage temperature and wind patterns. These systems could help create localized weather conditions suitable for human habitation, even while the larger-scale terraforming efforts are still underway. Terraforming Venus presents a series of unique and daunting challenges, from its extreme surface temperatures and dense toxic atmosphere to its slow rotational period and lack of a protective magnetic field. These challenges are unlike those faced on Mars or any other celestial bodies, requiring innovative and unprecedented solutions. While the obstacles are immense, the potential rewards are equally significant. A successful terraforming effort on Venus could result in the creation of a second Earth, a new home for humanity with the potential to support life, culture, and civilization. Overcoming these challenges will require a combination of scientific ingenuity, technological advancement, and global collaboration, paving the way for humanity's expansion into the cosmos with the realization of one of the most ambitious projects ever conceived. The idea of terraforming Venus is more than just a scientific or engineering challenge. It represents a bold vision for the future of humanity, a vision that pushes the boundaries of what is possible and redefines our relationship with the cosmos. This vision is not merely about transforming a hostile environment into a habitable one. It's about the broader implications of such an endeavor for human civilization, our place in the universe, and the future we wish to create. The concept of terraforming Venus forces us to confront the limits of human potential and challenges us to push beyond them. Historically, humanity has always sought to explore and conquer new frontiers, from the first oceanic voyages to the exploration of space. Terraforming Venus is the next logical step in this journey, a step that demands the best of our creativity, determination, and technological prowess. Undertaking such a massive project would require a profound shift in how we think about our capabilities as a species. It would mean developing technologies that, until now, have only existed in the realm of science fiction, such as planetary scale climate control, artificial magnetic fields, and advanced ecological engineering. More importantly, it would require a shift in mindset, an acknowledgement that we have the power to reshape entire worlds, and that doing so is not just a dream, but a real possibility. This vision also speaks to the resilience and adaptability of humanity. It suggests that even in the face of seemingly insurmountable challenges, we can find ways to survive, thrive, and expand our horizons. In this sense, terraforming Venus is not about survival. It's about flourishing in an entirely new and unprecedented way. Terraforming Venus would mark the beginning of a new era of space exploration, one that goes beyond mere exploration and moves into the realm of planetary engineering and colonization. Up until now, our efforts in space have been focused on exploration, sending probes to distant planets, landing astronauts on the moon, and studying the composition of other celestial bodies. While these endeavors have expanded our knowledge of the universe, they have largely been about observing and understanding rather than transforming. The effort to terraform Venus would represent a fundamental shift in this approach. It would signal our transition from being passive observers of the cosmos to active participants in its shaping. By taking on the challenge of terraforming a planet, we would be asserting our presence in the solar system and demonstrating our ability to mold environments to suit our needs, and maybe showing that, as a planet, we can really work together. This new era of space exploration would also require unprecedented levels of international collaboration. The sheer scale of the project means that no single nation could undertake it alone. Instead, it would necessitate a global effort, with countries, private companies, and international organizations working together towards a common goal. This collaboration could set the stage for a new kind of international relations, one based on shared goals and mutual benefit rather than competition and conflict. The vision of terraforming Venus has the power to inspire future generations in a way that few other endeavors can. It is a grand challenge that captures the imagination and offers a compelling narrative of progress, innovation, and the potential for a better future. For young people growing up in an era of rapid technological change and environmental uncertainty, the idea of transforming an entire planet offers a powerful message that we have the ability not only to address the challenges we face on Earth, but also to create entirely new possibilities beyond our home planet. This vision can serve as a catalyst for education and innovation. The scientific and engineering challenges associated with terraforming Venus could drive advances in fields such as climate science, materials engineering, biotechnology, and space travel. These advances, in turn, could have a spillover effect, leading to new technologies and solutions that benefit life on Earth as well. Moreover, the prospect of terraforming Venus could help rekindle a sense of wonder and excitement about space exploration. In recent years, there's been a resurgence of interest in space, driven by initiatives such as SpaceX's Mars ambitions and NASA's Artemis program. Terraforming Venus could build on this momentum, offering a vision that is even more ambitious and far-reaching. It could inspire a new generation of scientists, engineers, and explorers to dedicate their lives to the pursuit of knowledge and the expansion of human presence in the cosmos. At its core, the vision of terraforming Venus is about creating a second Earth, a world that could serve as a home for future generations of humans. This idea has profound implications for the future of our species. As the population of Earth continues to grow, and the challenges of climate change, resource depletion, and environmental degradation become more pressing, the need for new, habitable spaces may become increasingly urgent. Terraforming Venus offers the possibility of relieving some of the pressures of Earth by providing an alternative habitat for humanity. Unlike Mars, which would require significant adaptation to its harsh environment, a terraformed Venus could be made to closely resemble Earth in terms of climate, atmospheric composition, and surface conditions. This would make it a more viable and attractive option for large-scale human settlement. Creating a second Earth also speaks to the long-term survival of our species. By establishing a permanent human presence on another planet, we would be safeguarding our civilization against potential existential threats, such as asteroid impacts, supervolcanic eruptions, and other catastrophic events that could threaten life on Earth. In this sense, terraforming Venus is not just about expanding our horizons. It's about ensuring the continuity of human civilization for millennia to come. While the vision of terraforming Venus is undoubtedly exciting, it also raises important ethical questions. As we consider the possibility of transforming an entire planet, we must grapple with the moral implications of such an endeavor. Do we have the right to alter another world, potentially erasing any existing ecosystems or geological features? What responsibilities do we have to future generations, both on Earth and on Venus? These questions highlight the need for a thoughtful and deliberate approach to terraforming. It's not enough to simply have the technical ability to transform a planet. We must also consider the broader consequences of our actions. This means engaging in a global dialogue about the ethical, environmental, and social implications of terraforming, and developing a set of principles or guidelines to ensure that the project is carried out in a responsible and sustainable manner. The vision of terraforming Venus, therefore, is not just about technological progress. It's also about the evolution of our values and ethics as a species. It challenges us to think deeply about our place in the universe and the legacy we wish to leave for future generations. While the idea of terraforming Venus may seem like science fiction, it's a vision grounded in the principles of science and engineering. The challenges are immense, but they are not insurmountable. With advances in technology, a deep understanding of planetary science, and a commitment to long-term planning and collaboration, the dream of transforming Venus into a habitable world could one day become a reality. The vision of terraforming Venus represents the culmination of centuries of human inquiry, discovery, and innovation. It builds on our understanding of the natural world and our ability to manipulate it in ways that benefit humanity. It also represents the next frontier in our quest to explore and inhabit the cosmos, offering a bold and inspiring vision for the future. The vision of terraforming Venus is more than just a scientific project. It's a bold statement about the future we want to create. It's a vision of a world where humanity has the ability to shape entire planets, where we have the tools and knowledge to overcome even the most daunting challenges, and where we work together to achieve common goals that benefit all. This vision is not just about survival or expansion. It's about flourishing in ways that we have never before imagined. It's about creating new opportunities for life, culture, and civilization, and about ensuring that the story of humanity continues for generations to come. In the end, the vision of terraforming Venus is a vision of hope. Hope for a future where we can overcome the challenges we face on Earth, where we can expand our presence in the universe, and where we can create a new world that reflects the best of what humanity has to offer. It's a future worth striving for, and one that, with determination and ingenuity, we can begin to build today. As we conclude our exploration of Venus and Mars as candidates for human colonization and terraforming, it becomes clear that both planets offer unique opportunities and challenges. Mars, with its well-documented surface, less hostile atmosphere, and extensive research, has long been considered the most realistic destination for human settlement. Its relatively temperate climate, accessibility, and the vast amounts of data we've gathered make it a familiar and seemingly safer bet. However, Venus, the planet often overshadowed by its red neighbor, reveals itself as a contender worthy of serious consideration. Despite its extreme surface conditions, ranging from crushing atmospheric pressure to searing temperatures, Venus offers distinct advantages that make it an intriguing alternative. Its proximity to Earth, similar gravity, and the potential for harnessing its abundant solar energy present compelling reasons to view it not as a distant second to Mars, but as a strong competitor. The prospect of creating a more Earth-like environment on Venus, with the possibility of stabilizing its environment and utilizing its rich resources, highlights the planet's potential to be transformed into a second Earth. While the challenges are significant, they are not insurmountable. With advances in technology and a deep commitment to planetary engineering, the dream of making Venus habitable is within the realm of possibility. In comparing Mars and Venus, We're not just evaluating 2 planets. We're considering 2 distinct visions for humanity's future in space. Mars represents a more straightforward, perhaps more achievable goal in the near term. Venus, on the other hand, symbolizes a bolder, more ambitious vision, one that challenges us to rethink what's possible and pushes the boundaries of our technological and scientific capabilities. As we look at the future, the choice between Mars and Venus is not necessarily an either-or proposition. Both planets offer valuable lessons and opportunities for expanding our presence in the solar system. By continuing to explore and understand these worlds, we can lay the groundwork for humanity's next great adventure, whether that take us to the deserts of Mars or the clouds of Venus. The path forward will require careful consideration, international collaboration, and a willingness to take on unprecedented challenges. But in doing so, we open the door to a future where humanity is no longer confined to one planet, but is instead a spacefaring civilization, capable of thriving in multiple environments across our solar system. Ultimately, the comparison between Venus and Mars is more than just a technical analysis. It's a reflection of our aspirations as a species. It invites us to dream big, to push the limits of what we believe is possible, and to envision a future where we not only explore new worlds, but also transform them into places where life can flourish. Whether the first steps take us to Mars or Venus, the journey itself will be one of the most significant undertakings in human history, a journey that promises to redefine our place in the universe. Thanks for tuning in. I hope you found this video informative and thought-provoking. This is the point where others tell you, if you enjoyed it, give it a thumbs up and consider subscribing for more content just like this. But we know that kind of thing is for losers. Don't be a loser. And as always, I welcome your feedback and your ideas for future videos in the comments section below. Until next time, keep exploring, keep learning, and keep embracing your inner nude, dude.